problem today is to compare 4/6 to 4/8. Try and figure out which fraction is going to be larger. The past 2 days we've been working on comparing with visual models, looking at bar models to compare. Okay? I know that I'm comparing 4/6 and 4/8, so I'm going to start with just a visual model of one of those fractions. Since 4/6 is first, I guess I'll start with 4/6. I'm going to partition into 6 equal sized pieces as best that I can. Pretty close to equal. And then I'm going to shade in how many? How many am I going to shade in? I've partitioned into 6. My denominator tells me to partition into 6. How many should I shade, Eva? 4. A lot of you keep forgetting this part. You partition into 6, and you're like, okay, I'm done. You still have to do the shading. That numerator tells you what to shade in, tells you how many pieces you're using. In this case, I'm shading in 4 for 4/6. What's my next step when I need to compare to 4/8? What do I need to do now? Eva, what do I need to do now?
You need to do a model the same size.
Yeah, we talked about how important it was if I'm going to compare something, I need to make sure they're the same size. Fractions are all about being fair, and if I don't have something that's the same size, that's not really fair. What am I going to partition that bar into? Jake? How do you know it's going to be 8 equal parts?
Because second one is 4/8 and you're going to split it into 8 equal parts.
Good. My second fraction is 8, so I know I'm going to partition my bar into 8 equal pieces. As equal as I can get it. Now what? Eleanor?
Shade in 4 and negative and
Yes. I'm going to shade in 4. Eleanor, which part of my fraction tells me to shade in 4?
the numerator.
The numerator. Alright, I've shaded in my fraction pieces. They both have 4 shaded in, so how do I know which one's bigger? Both of my fractions have 4 shaded in. How do I know which one's bigger? Taylor?
You know which one's bigger? It's because at the top. There's only 2 left. 2 left that large. There's 4 left that large.
So my top fraction, you're telling me, is closer to being one whole, whereas my bottom fraction has a little bit more to go? Yeah, that's how we know which fraction is bigger. We're looking for the fraction to be closer to all the way shaded in. In this case, we can see that 4/6 is very close to being all the way shaded in, all the way to a whole. 4/8 still has a little bit ways to go. So I'm going to write my comparison statement down here. We talked about this in my small group, greater than or less than. We kind of reviewed this. Which way is my greater than or less than symbol going to go? Think about it like a mouse. Aiden? Which fraction is greater? Tell me that.
4/6.
4/6. So my mouth is going to be facing 4/6 because it's going to be larger. So I would read this as 4/6 is greater than 4/8. Any questions? Are we good? Taylor?
So, is it basically like the lower numbers are the bigger numbers, but the higher numbers are the smaller numbers?
Don't think of it like that. Think of it more as if I have a smaller number, I'm having to share with less people. So I can get more of whatever I'm sharing. But if I have to share with a lot of people, I'm not going to get a big piece. Does that make sense? Like if I share one pizza with everybody in here, I'm going to have little tiny pieces. But if I share a pizza with just Peter and I, we're going to have big pieces. Okay? So it's depending on how many people you're sharing. Okay? Matthew?
When you compare fractions, do they always have to be cut like that?
For this model, yes. Now, you can do other models, and we're going to talk about that today. We're going to talk about how to use a number line. But for this model, yes. And some of you, we talked about this, we don't want to shade in pieces. Like, we don't want to put this over here. Yes, you can, and that still be worth 4/8. But does that help your brain really decide which is bigger? No, man, we want to make it as easy on our brain as we can. Okay? Does that make sense? Alright. So we're going to solve this problem. It says Tessa and Andy were talking about how much pizza they ate last night at the party. They were trying to figure out who ate more. Tessa ate 2/3 of a small pizza, and Andy ate 4/6 of a small pizza. Andy said he ate more because 4/6 is bigger than 2/3 because the denominator and the numerator are both larger. Tessa thinks that they ate the same amount because 4/6 and 2/3 are equivalent fractions. Who do you agree with and why? I would try and solve this problem in your notebook. We're going to talk about it in a moment. I see a lot of model drawings. Somebody talk me through, what did you do? Try and solve this problem. What did you do? Lee, what did you do?
I drew a model for 4/6 and 2/3.
Okay, did you do 4/6 first? Okay, so you broke up our top one into 6. Yep. As equally as you can, right? How many did you shade in on that top one? 4, because beautiful. Numerator tells us how much to use. In this case, our numerator is 4, so I'm going to shade in 4/6. Where did you do your second model?
I did it under my 4/6.
Like this? Good. Where did you partition that one into?
3 equal pieces.
Why?
Because the denominator tells you how many pieces you split under.
Beautiful. And how many did you shade? 2. Very good. So you're on a roll today. All right. Who are we going to agree with? We have our model. We know that. Wait, what? Tessa ate. This is Tessa T for Tessa. She ate 2/3, and then our top one we have A for Andy, and he ate 4/6. So we know that Andy said he ate more because 4 and 6 is bigger than 2 and 3. The denominator and numerator are both larger. That's true. 4 is a larger number than 2, and 6 is a larger number than 3. Tessa thinks they ate the same amount because 4/6 and 2/3 are equivalent fractions. What do we think? Who are we agreeing with? I need to make sure I have a Y as well. You need to have this in your notebook. Who do you agree with and why? Harley, who do you agree with and why?
I agree with Tessa. If you look at the model, they are the exact same way as space. Also, the last pieces, if you take that line out of the means,
This looks to me very similar to the fraction matches. Doesn't that look how we would set up fraction matches? Or with our fraction pieces, we would uncover the whole? Yeah. Beautiful, Harley. She said the shaded pieces are equivalent. They're worth the same amount. They look a little different, but they are worth the same amount. So we're agreeing with who? Tessa. Are there any questions about this one? This is tricky. It's going to be tricky with thirds, because thirds are hard to make equal size. And that's why I say neatness counts, because sometimes if you drew your thirds off, it might look like one is bigger than the other. Does that happen to anybody? Yeah, it's tricky. Thirds are very tricky because you can't just split it in half and have that piece. Kaylin, question?
I was thinking that Andy, because that weren't shaded, but now I'm thinking. I said she had a bigger piece, but they would still equal the same exact amount.
Good. So Kaylin was thinking at first, she was thinking, well, I see that Andy has 2 pieces to go, where Tessa only has 1 piece to go. So maybe that has something to do with it. Kinda. But if we look at just the unshaded amount, those, whether it's 2 pieces or 1 piece, they're worth the same amount. You see what I'm saying? So that was a good thought, Kaylin. I know exactly where you were going. However, we want to look at those shaded pieces, and we see that they're going across our hole at exactly the same amount of space. No part is shaded farther. Okay. Yes?
I kind of drew off my thirds, but I got it right.
Yeah. Thirds are tricky to draw, so just be careful. Try to have neatness as best you can.
I was wondering if this is really this question, but it's bigger. But what is the equal? What side of it? Equal side. An equal side.
That was one of those questions where it was complicated, but then you're like, oh wait, I know the answer to that. So Lauren said, what sign would we put in the middle because they're equal? Well, it's an equal sign. I know, we've been talking a lot about greater than or less than, so it's weird to think, well, these aren't greater than or less than, they're just equal. Good question. Kaylin, what's up? A fraction can be larger than some other fraction. Alright, we're going to keep on moving on. Alright, remember, you have this written down, but remember, when you compare fractions, the whole has to be the same. Has to be the same. 100% has to be the same. Fractions are equal. Fractions are equivalent. Fractions are fair. They can be equivalent. And they are all about being fair. All about equal sized pieces. Wholes have to be the same size if we're going to start comparing fractions. All about fairness. You should already have that in your notes. Yes? Yes. Alright, so now we're going to think about this question. How can I use number lines to help show equivalency, like we just did with Tessa and Andy, show that 2 fractions are equal, or to compare fractions? I want you to think about this in your head. You're going to have a minute to think, how can I use a number line to help me? I encourage you to flip back when we start doing number lines. And then I want you to turn and talk to a neighbor in just a few moments. But for right now, you're thinking in your head, how can I use number lines to help me show equivalency and or compare fractions? If you're thinking in your head, I might want to look back to when we did number lines. What?
Do we do that on the
Kind of. Yeah, if it helps you to write down what you're thinking, go for it. turn to the person or persons at your table. And I want you guys at your table. I want you to talk. How can you use number lines to help me show equivalent to your compare fraction? You can talk about number
And then I just draw it really.
or compare fractions. What did you and your partner talk about? Bryce, what did you and your partner talk about?
So, if I have a number line and I jump 4 times, and then it equals to another half of a number line, then that 4 pieces will be equal to 1/2.
Okay, so I'm hearing you say a couple of things. I'm hearing you say, are there going to be one number line or two number lines?
2.
Okay, so Bryce thinks 2 number lines. I heard a couple of you guys talking about that too. And then he's talking about jumping. Remember when we do number lines, we count the spaces. We're not counting the tick marks, we're counting those spaces. So I like that Bryce is talking about jumping because he's showing me that he's actually counting the spaces. Good thought. Aiden, what did you and your partner talk about?
We were talking about how you can use 2 number lines that are equivalent and you compare both of them.
What do you mean by 2 number lines that are equivalent? Talk to me more about that. Riley, you want to help clarify?
So first you put one whole number line. You could put other separate number lines below it as the other pieces you need to make a whole.
Yes? Is that what you mean? What do you mean?
It has to be the same length.
Why would my 2 number lines have to be the same length? Why would that make sense? Aiden, back to you. Go for it.
Because fractions are always the same.
And what does a number line for us stand for? Number lines can go on for lots of things, but what have we been using our number line to represent? Alyssa?
Fractions.
The whole thing. The whole. Now, fractions can go beyond the whole. Right? If we have more than a whole, we can show that in a fraction, but for most of us, we've been doing fractions as a whole. Number lines can help us, just exactly what Bryce and Aiden and Riley were talking about. We're just going to draw 2 number lines. Just like we would do 2 models for our visual model. You're going to have to let them into the subscription. It's unlocked. It's not unlocked. So when we use number lines, it's going to be set up just like visual models. You're going to have to draw 2 of them. They're going to have to be the same length. And we're going to go about it that way. Okay? Alright, so let's look at 2/4 versus 1/2. So I have 2 number lines. They're exactly the same length. Remember, we draw number lines margin to margin across on our blue lines on our paper. We're going to compare 2/4 to 1/2. I have 2 number lines, and now what do I do? What would I do now? Then what would I do now? Which one? Sure, it doesn't really matter which one I break up. I'm going to put my starting line and my ending line first. What fraction is going to be my starting line? What fraction is going to be my starting line? This is a tricky one. Jake, do you know? It's not going to be 2/4. That's tricky. We're not going to start at 2/4, but we will be able to see it. Tricky, Kate. 0/4. We know that my line's going to be split up into 4, but if I'm at the beginning of my line, have I used any?
No.
No, I haven't used any, so I'm at 0/4. What's going to be the end of my line? So I'm trying to just have a hole. Okay, then 4/4. Alright, what's going to go on the inside of my number line? Or on the inside of my top number line, I should say, Peter.
You split it into 4.
I partition or split into 4s. I'm going to go in the middle first. That's an easy part for me to find. And then I'm going to partition that way. Do I have... Wait, I only have 3 tick marks. I only have 3 tick marks. Lene, is that a problem?
No, because you don't count the tick marks. You count the space.
Oh, I count the spaces. Let me count. 1, 2, 3, 4. 2. Yeah, I have 4 spaces, and that's what I was looking for. I'm going to label them. This is 1, 4. What's after 1, 4? 2, 4. 3, 4. 3, 4. 4. Perfect. All right, I have my top number line done. What about my bottom number line? What's going to be my starting fraction, Mateo?
0. Oh, wait.
0 halves. So we said 0 halves. Because I'm going to partition into halves. But I'm not using any pieces yet, so I'm still at 0. What's going to be my end line? Natalie?
2 halves.
2 halves. AKA 1 whole. What do I need to partition now? Eva? Half. All right. Now, when I use a number line, Bryce is right. I'm going to use that jumping method. Sometimes I like to do circles to remember that I'm counting the spaces. I'm doing 2/4. So you can either jump or you can do a circle like this. 1/4. 2/4. If you prefer to jump, it might look like this. 1/4. 2/4. I don't care. Whichever works for you. I don't care. Whatever works for you. Now, did we go from 0/4 to 4/4? Is that the fraction we're trying to find? No, I'm trying to only find 2/4. So once I get to 2/4, I'm going to stop. Same with my bottom fraction. I'm trying to get to only 1/2, and so I'm going to make my circle or my jump to 1/2, and then I'm going to stop. Whichever way works for you, I don't care. Take you with us. Alright, so let's do our comparison now that we have this in our notebook. Is it going to be greater than, less than, or equal to? Get your notebook open. Come on. Alyssa, what you think? Yeah, so the way we use number lines to show equivalency or to compare is we simply look at the distance. It's the same setup as our bar model in terms of how we figure out which fraction is bigger. I can tell that these number lines stop at the exact same spot. That shows me they're worth the same amount. That shows me they're equivalent. Does that make sense? Alright, we're going to try some others. Alright, we're going to do 3/8 versus 3/4. Alright, talk to me. How many jumps or hops or whatever am I going to do for the first one? Corbin, how many hops am I going to do for the first one? 8. I am not going to do 8. Oh, nope. Look at that fraction again. Look at what I'm comparing. I'm comparing what?
3. You're going to do 3.
I'm going to do 3 because my numerator tells me I'm using 3 pieces. I'm going to hop 1, 2, 3, and stop. I want to stop at 3/8. about my bottom fraction? What about my bottom fraction? Here?
You do 3 halves
Why?
because the numerator is 3.
Yeah, well, I want to get to 3/4. Here's 3/4. My numerator is 3, which tells me how far to go. Now looking at your hops and looking at how far across our number line we went, is it going to be greater than, equal to, or less than?
Oh,
Greater than, equal to, less than. Make sure you say the whole thing. Mateo?
3/4 is greater.
Okay, so we would say 3/4 is greater than, or 3/8 is less than 3/4. Remember we talked about how that's a mil, and the top wants to keep the largest piece. Alright, I'm going to have you do, I think it's 3 in your notebook. Go ahead and do these 3. I want to see the number line strategy in your notebook. If you need help, just raise your hand. No, there's plenty of room. I can see it. So, go ahead and do these 3. Make sure you have the comparison